somebody start me off here. If I have 2 points,
E equals.
and I'm going to call the points to make them totally general. I'm not going to be specific at all. When we want to write down a formula, we want to write it as generally as possible so we could make it fit any situation. And so to do that, my 2 points, I'm going to call x1, y1, and x2, y2. Now somebody briefly here explain to us, what do the 1s and the 2s stand for now? They're not exponents, are they? They're not superscripts, they're subscripts. What do they mean? Okay, yeah, it's going to help us make our general formula for distance, but they keep track of which point we're dealing with, right? The 1s, x sub 1 and y sub 1, go with one of our 2 points, and the x sub 2, y sub 2 go with the other of our 2 points. So ultimately, those are going to be numbers. We're going to replace those with numbers, right? Those are the ordered pairs that represent the 2 points that we're finding the distance between, right? So now, in terms of those very general points, x1, y1, and x2, y2, what is our distance formula? Distance equals what?
E equals that little square.
Okay, square root of a bunch of stuff. Now, what goes under the radical?
Parentheses.
Okay, yeah, so parentheses. Now, the way we say this in math, we'd say the quantity, what?
X2 minus X1
Okay,
to the second power.
x2 minus x1 squared plus, good.
The quantity Y2 minus Y1.
Good. And then all we're ever going to do with distance stuff is we're just going to plug in the appropriate numbers and simplify that down to a single answer. Okay? So let's take this example. Let's plug in the specifics here. So our distance equals square root of what? So somebody raise your hand. Somebody help me out with the first part. Yes, Casey. Say it again. Okay, almost 6 minus what? Okay, minus -5. You subtract the x's. So 6. Now I want you to watch this. This is going to seem pretty childish and like this is grade schoolish, but this is really helpful. When we're subtracting a negative, my wife teaches 6th grade in Hermiston, and she calls it bink bonk. And this is what she does. If she's subtracting a negative, she says bink bonk. I don't know why she says bink bonk. But anyway, just the two marks you make, instead of saying minus negative, you just say minus negative and turn it into a plus sign, because subtracting a negative is equivalent to adding, right? So then we've got 6 minus -5 becomes 6 plus 5 squared, right? Everybody sees where we got that, right? The x minus the x. Now what? Plus
-2 minus 4.
okay, -2 minus
No ping pong.
4 squared. Okay? So let's take it one more step. 6 plus 5 is 11.
Squared.
Okay, now what about this? -2 minus 4
-6.
is -6. When I square -6, what's my answer going to be?
36.
Positive 36. Okay. In fact, that's always going to happen. Whenever I square a negative number, I always get a positive answer, right?
Mm-hmm.
So here's a great hint that if you take this with you, if you do this, this will save you from making hundreds of math mistakes throughout your math career. Whenever you square a negative, always square the positive instead, because you're going to get the same answer without running the risk of making a mistake. And it's really easy to make a mistake. On a calculator, for example, if I do, yeah, if you forget parentheses, if I say like -6 squared, it's not going to give me positive 36. It mistakenly gives me -36, and if you're really rushing, sometimes you might forget to get rid of that negative sign. So, as a rule then, just always, if it's a negative number being squared, square the positive instead. Okay? So what is 11 squared?
Plus 36.
6 squared, 36. So I end up with square root of what, 157?
Which equals 12.53.
Okay, which is about 12.53 if I round it to 2 places. Okay. Now, is that answer exact? No, it's not. It's rounded, isn't it? It told us to round the answer. It's not exact. Okay, it is rounded. If I want an exact answer, I've got to do something a little different. Now, any questions on this? Does that make sense what we did? Yes, sir.
Yeah, I switched the numbers around, and I have
Okay, it should be the same either way. If I switch the numbers, so you subtracted these numbers from these numbers instead. Okay, so then we should have gotten, instead of 6 plus 5, we would have gotten negative 5 minus 6 squared, right? Plus, and then we would have gotten 4 minus negative, so bing bong, 2 squared, right?
Did you say bing bong?
I said bing bong. And then, so that's negative 5 minus 6 is what? Negative 11, but I'll just go ahead and square positive 11, right? And then 4 plus 2 is 6. So I should, at this point, I'm back on track and it looks exactly the same. Okay? So, but it's a good point though. Glad you asked that question. Doesn't make any difference which way, which ones you call point 1, which ones you call point 2. It'll work either way.
exactly, that's why I had the question.
Okay, good question. Good question. Otherwise, we okay on this one? Okay. Now here's the other one. These are a little different. It's another distance formula problem, but the wording is different here. It says something important. It says exact. An exact answer is different than the last one we gave because it was rounded. Now, exact answers in math, if they're going to be decimals, they have to be terminating decimals. They can't repeat. They can't just go on forever. They have to stop, right? Like 3/4 equals 0.75 exactly because it stops. But 1/3 equals 0.3333 forever, right? So we could never write that as a decimal because we'd always have to round it if we did. Another good example of that. Somebody tell, what's pi? You tell me what pi is. 3.14159, and some of you might know more, that's as far as I know it, but you could maybe know further than that. You could know it to hundreds of places, but it's not exact, is it? Now somebody tell me, what is pi exactly? I'll write it down for you. This is what pi is exactly. Pi is exactly this. Pi. Pi is exactly pi. That's what that number means. That symbol means the exact number pi. You can't write it as decimal, but you can write it that way. Okay. What does pi mean, by the way? This is interesting. I'll take just a little side note here, a little tangent. Yes.
It's the amount of, if you take the radius of the circle and put it on the circumference, it takes 30 times.
Okay, yeah, so now we're on to something. If we look at the circumference of a circle, which is just the distance around a circle, you might remember going back a couple of years, the circumference equals 2 times pi times the radius, right? Now what's another name for 2 times the radius in a circle? Twice the radius is what? The diameter, the distance all the way through the circle, through its center, right? So we could rewrite this as c equals the diameter, the circumference equals the diameter times pi. And now using your algebra skills, how would I isolate pi? If I want to solve for pi there, get it by itself, what do I have to do to both sides? How do I
Divide by 2, or
divide by what to get the pi by itself?
divide by 2.
No.
No.
D.
Divide by d. Divide.
Look at the top.
Divide both sides by d. And so then I get the pi by itself. And this is pretty cool. Look what pi equals then. Pi equals the circumference divided by the diameter. That's a pretty interesting result because I didn't specify the circle, did I? Could be a huge circle, could be a tiny circle, it doesn't matter. For any circle, the ratio of the distance around it, the circumference, to the distance through it is exactly what pi is. That's how we define pi. All right. But back to our problem. We want an exact answer. So we're going to do the same stuff we did before, only we're just not going to round the decimal. So what does the distance formula tell us here then? Square root of what? Somebody hasn't helped us out yet. Get us started on this. What goes into the formula? What numbers?
-13.
Okay. Okay, so negative 13 minus, okay, so minus negative, big ball, 15. Right, plus 15. Squared. Plus, what's the other quantity? Okay, 5 minus negative 3. 5 minus negative 3, so 5 plus 3 squared. And let's go ahead and skip a step here. Let's go ahead and find out what these numbers are, and we'll square them while we're at it. What's negative 13 plus 15? 2. If I square that, I get 4. 5 plus 3 is squared.
64.
Okay, so square root of 68. Okay. Now, if you put that in on the test or on the homework, then we do that. What'd you get back for an answer? 9 out of 10. Yeah.
Partially.
Okay, which is mostly. You got an A. It is the exact answer, but it's not simplified. Okay, I want to remind you about something important here. How do we simplify square roots? Anybody remember how to do that?
Yeah, square root in your calculator.
Well, that's going to give you a decimal, right? Yeah, so we want something other than a decimal. Okay, so there's a way to do this. Now, when we're simplifying square roots, the goal is always to get as much of the number as possible out of the radical. And the only way to do that is to find a perfect square factor of 68 in this case. In other words, we want to find the biggest perfect square number that divides into 68. And if there aren't any that do that, then we're done. And that's the exact answer. What is a perfect square? Now, remind me. What's the smallest perfect square that we talk about? I mean, 1 squared is 1, but that doesn't really help us. What's 2 squared? 4. So 4 is a perfect square. Okay, there's an example of a perfect square because it's made by squaring a number. What's the next one up the line? So 2 squared is 4, then 3 squared is 9. Okay, so keep going. What's after 9? 16, 4 squared, good. 25, 5 squared. 36, 49, 64, etc. Right? So let's look at that list and let's figure out what's the, if any of them, what's the biggest number that divides evenly into 68? Well, 64 obviously doesn't, right? 49, no good. 36, yeah. 25, nope. 16, no. 9, yeah. Does 4? Yeah, it does. 4 times what is 68?
17.
17. So I could rewrite this square root of 68. I could rewrite that as the square root. Instead of a 68, we'll write it as 4 times 17. We'll actually split it into 2 separate square roots. So it looks like this. Square root of 4 times square root of 17. And what is the square root of 4? 2. See why we did that? Because if we're able to divide away a perfect square, square root of a perfect square, we can just turn that into an integer, right? And so we got, look what we did. We started off with the square root of 68. We got some of that number out front in the form of a 2. And then we were stuck with a 17 inside the radical, and we can't go any further than that. There is no perfect square, obviously, that divides into 17, so we're done. That's prime, right?
So how would you put that in?
So how do you enter that? Good. So in Moodle, if this is the answer box in Moodle, how do we put that in?
SQRT.
Okay, squirt. Squirt is square root, SQRT.
What's the 2 for?
The 2 is, that's
Okay.
that 2, and then square root of, so squirt 17 in parentheses. Okay? And then if you hit the display response, it'll show you a nice pretty picture of 2 times the square root of 17. Okay? Make sense? Okay, last one I want to go through today. I like this one. This is a challenging one. This guy.
Oh, yeah.
Oh, yeah. Okay, so what about this? Point A has the coordinates 5, -8. Point C has the coordinates -4, 2. They're telling us BC equals 6. Angle ABC equals 90. Find AB. Oh, and before we jump into this, what does this mean? I said it, but what does that mean, BC?
Before Christ.
No. What's it mean in this case? Now, if I wrote it this way,
Right?
if I wrote it this way, BC means what?
Before.
Well, what's that mean if I put that symbol over the top? Line BC. It means a line through the points B and C, right?
I like that answer.
Okay, what if I write it this way? What's that mean? Segment BC. So that means the segment connecting the endpoints B and C, right? Everybody with me? Okay, so then what does this mean? If I write it this way, what's that mean? Just plain old BC with no symbol on top. With
Points.
Without the symbol, we'll talk more about this in geometry, but without the symbol, it's not a geometric thing anymore. Now it means a number. And the number we could represent as the length of the line segment, which connects B and C. But in the context of what we're talking about today, what's another way of saying that? The length of line segment BC, we could also call what? I heard it. Distance. Distance between B and C, right? Isn't the distance between the endpoints the same thing as the length of the line segment? Right? Okay, so it's just a distance. Okay. Now, that's a lot of information. This is clearly a case where you've got to draw yourselves a picture. And this is a skill that takes a little bit of practice to develop in math, drawing a picture that's representative of a situation. So let's go through one of these together. How about? Needs a little more room. So the first point A, was at 5, -8. So that, how do I do that if I start at the origin? 5 in which direction?
Right.
To the right. Okay, 1, 2, 3, 4, 5.
Down 8.
Down 8. 1, 2, 3, 4, 5, 6, 7, 8. So right about there. Let's make it blue. So there's point A. Those coordinates. Now point C was at -4, 2. How do I get to -4, 2?
Left forward.
Okay. And then
Up 2.
up 2. Right about there. Okay, so there's point C. -4, 2. Okay, so we're trying to find this distance. Well, actually, we're not. In this case, we're not really trying to find that distance. There is a distance there we could find, right? We could call it AC if we want to. But what they've told us is there is some other point B that is related to A and C in such a way that the angle ABC is a 90-degree angle. So I could make a right triangle out of those 3 points then, couldn't I? If I put point B, we don't know exactly where it goes, but we want to draw a picture that represents where it could go at least. And then we'll solve for the number parts later. I could do something like this, couldn't I? What if I want to make that a right angle? I could make those 2 lines cross at a right angle like that. It's not exactly a right angle, but you get the idea, right? And then I could call this point right here. Whoops. Oh.
Zach here, can I talk to him?
Zach, yeah. So there's point B, right? Now we know that point BC is 6. So where am I going to put that 6 on this triangle then?
Hazel. In the middle.
Where's it go? So that's the distance between B and C.
So if you
Okay, so right here, isn't it? That's the distance. That one becomes 6, right? Now the original question, what was it asking for? It wanted us to find AB. And what's that mean? Distance from A to B. So if I go back to our triangle, this is what it's wanting us to find. So let's call it X. That's the unknown that we're trying to find. Let's call that X. Now look what we got there. Okay, we've got a right triangle. You got to go back down memory lane a little bit here, but I want you to tell me if I've got a right triangle like this, what can you tell me about the relationship between the lengths of the sides of that right triangle? What do you think? Yeah, we know the Pythagorean theorem, right? The Pythagorean identity. If we know that we've got a right triangle with legs A and B, and a C is the hypotenuse, so that's the long side that's opposite the right angle. And we'll go through this more as the year progresses, but you've seen this before, I'm sure. We know A squared plus B squared equals C squared. There's the Pythagorean identity or Pythagorean theorem. So look at our right triangle. We've got some stuff here. We could fill in specifics for those, couldn't we? right? We know that this side is 6. We know that one is x. AC, we don't know yet, but we could figure out, right? That's a distance, and we know the coordinates of B and C. So we could use our distance formula to find out what that distance actually is, right? Right? So let's do that. So if I want to find that distance, AC, we just have to plug in the numbers and simplify. So what are the numbers that go into the distance formula?
-4 minus 5.
Okay, so we got -4 minus 5
2 minus
plus 2 minus negative, so plus 8, right? And what's that give us? Well, -4 minus 5 is -9, so we can just make that a 9 squared. And then 2 plus 8, 10 squared. And what's 9 squared?
81.
10 squared. So then that's just the square root of 181, right? So let's put that in there. Let's write that now that we know that. There we go, right? So we could even go over to our right triangle now, and we could plug in, instead of the A's and the B's and the C's, we could just plug in numbers, right? We said that the hypotenuse in this case was the square root of 181. One of the sides was 6, right? See what we're doing with this? So this is 6, and then the other side we called x. That was what we were trying to find. Whoops, gosh. That make sense? Compare that to, isn't that the same, I've kind of turned it around, I guess, a little bit, but it's the same triangle as that one, isn't it? Right, our hypotenuse opposite the right angle was the square root of 181. One side was 6, one leg was 6, and the other leg was x. Okay, so what does the Pythagorean theorem tell me about that? What equation can I set up? Okay, say it again. 6 squared, right? Plus, because that's like A, plus, well no, that's the hypotenuse. That's got to be on the other side. That's the big one. Plus x squared equals,
Square root of 181 squared.
okay, and what happens if I square a square root, or if I square root a square?
The square root of 181.
Yeah, they cancel out, don't they? For example, if I take 3 squared is 9, square root of 9 is back to 3 again, right? They cancel out. So that's handy. That just becomes a 181. What's 6 squared? So 36 plus x squared equals 181. And we're just looking for x, right? That's the length of that side. How am I going to get that solve for x there?
Minus 30.
Good. Subtract 36. So x squared equals 145. And then the last step? Square root. Sure. Okay, so x equals the square root of 145. And we'll just turn it into a decimal.
It's 12.04.
12.04. And we got it.
That takes a long time.
Yeah, it does. There's a lot of steps in that problem, but we did it, right? We found that missing side link. Okay? All right. I would wager that's probably good for one day.
Yeah.